Hi everyone, I hope you can hear me and the audio quality and video quality is good. So let's wait for a few more seconds and we can get started. I can hear myself. I hope the audio and video are working. So let's get started. So in today's session, we'll be learning introduction to computer vision using PyTorch. So while exploring computer vision, we'll be learning about this dataset. So this dataset is called CIFAR10 dataset. So what we are going to do is we are going to pick any two classes from these images, and then we are going to build a computer vision deep learning model so that classifies those two classes. So for programming, we will be using PyTorch, and the environment we are using is Google Colab. So if you are a beginner and if this is your first session, this is Google Colab. You can just Google Colab and you can see this screen. Here you can choose runtime, change runtime type, and you can choose GPU. And you can, if the version is free, you will have only standard. If you're paying like $10 per month, you can choose premium. Click save. So by the way, this is our forum. You can ask any questions here. So I'll be keep checking on this and I will answer that. Runtime, change runtime type, GPU premium, click save, then click connect. So after clicking connect, it's going to create a virtual computer with GPU installed for you on Google server. And you can check what GPU you got by using NVIDIA SMI. Let me zoom a little bit. So here I have got 800 GPUs, which is pretty good. So before starting our session, let me share this with you so that you can get access to the code as I write. Copy link, done. So for this project, we'll be writing code from scratch. It's a live coding, but we'll be also using some ChatGPT to write some boring programming things. So that might speed up our learning. So this is the one I'm experimenting. This is the first time I'm doing here. So let's start with normal data, and if we get stuck, we can use ChatGPT to help us. Cool. So, and if you're not aware of ChatGPT, so ChatGPT is like it's like you can ask any questions and you can get some answer. We'll see as we go progress. Cool. So I'm going to import some normal Python libraries. Import numpy snp, import pandas spd, import matplotlib.pyplot as plt. Then what else? Let's use torch. Okay, so maybe before going there, let me explain the problem and then we will dive into programming things. So today we are going to learn computer vision. So in computer vision, we have images and some label. Then we built a model. So this model learns some parameters, which is weights and biases. So initially those weights and biases are random numbers. Then during training, these weights and biases will update itself, and it can be more meaningful in classifying the images. Cool. So the dataset we are going to use is CIFAR10. So this CIFAR10 has 10 classes, right from aeroplane, bird, dog, and few more. Cool. So this dataset we can download from internet, and then we can put it in a folder. Then we will construct a deep learning model. The model takes those images and label. It's going to make some predictions. So these predictions are like, okay, this is airplane, this is bird, this is cat, like that. Then once we get the predictions, we can compare that with the label. And you can calculate the loss. So if the label is dog and the prediction is dog, which means there is no error because we accurately classified. And if there is any misclassification, we will have some loss function, and the loss function will tell you how much the misclassification is. And after that, these weights and biases will change its number a little bit so that the loss gets low. Okay, that's the process of training. So during training, we calculate the loss and we update those weights and biases so that the loss goes down. So that's the goal of the project. And we know that we will be using CIFAR10, and we are getting those dataset using PyTorch. So that's one thing. And let me talk about the things we are going to learn today. So we will learn how to download dataset from using PyTorch. And PyTorch has dataset and DataLoader. We will learn that. Then how to transform your dataset. Then we will see how to normalize the dataset. So while explaining all these things, I will explain why we are doing all these things. So you don't need to worry about these things now, but we will see one by one. So after normalization, we can build a model. Then we can construct a loss function. Then we can choose an optimizer. Then train a model. So these are the things we are going to code and learn today. So we'll see one by one. Cool. So there is a module called Datasets that comes from Torch Vision. From Torch Vision, import datasets. So we are going to use CIFAR10 dataset. So let's download CIFAR10 dataset from Datasets module. CIFAR10. So this datasets classes, this dataset module has so many datasets. You can see it here, Caltech 101, and there are so many. So we are going to use CIFAR10. So there is another version called CIFAR100, which has 100 different classes. But for simplicity, let's start with CIFAR10. So datasets.cifar10. We need to mention where we are going to download. Myself, just a current directory. Then we are downloading a training data, so we have to set train equal to true and download equal to true. So when you choose download equal to true, it checks this path. If the data is there, it won't download, otherwise it will download. So we got training data, and let's write code for validation data. C4 10 val datasets dot C4 10, same directory, train equal to false because we need a validation dataset, then download equal to true. So this will download datasets. So in PyTorch, dataset class has two things. One is it has length. Then another is get item. So this length tells you how many data points are there in the data, number of data, and this get item acts like a index. So we can index any dataset and we get the data. So let's try to use length of C4 10 50,000. Good. So let's there are 50,000 data points. Let's try to access the first dataset, C4 10 zeroth index. Let's see what we are getting. Oh, sorry, C4 10 0. So we are getting an image and we are getting a label 6. Let's try to find how many classes, what are the classes in C4 10. We can use ChatGPT for this. So while doing this, we'll be also learning something called prompt engineering, which means asking some right questions and getting answers. If the answers are not clear, we will try to change our questions. So this is a useful skill to practice. We'll be also practicing those things here. So our question is, we want to know what are the classes of C4 10. Okay, airplane, automobile, bird, cat, deer, dog, frog, sheep, truck. Okay. So class names, airplane, automobile, bird, cat, deer, dog, frog, horse, sheep, truck. Cool. So here we are getting 6, which is 0, 1, 2, 3, 4, 5, 6. I suppose that's frog. Let's display the image. Okay, yeah, this is a frog. Okay. Okay, so now maybe write a function, maybe write some programming that takes C4 10 classes and display one image in each class. Let's use ChatGPT for that. So our goal is write code to show each example from each class in PyTorch. C4 10. I think our name is C4 10. Yes, C4 10 data using matplotlib. Okay, so this looks good. Maybe let me use my code and then show that. Okay, let's run this. If there is any issue, we will debug. Okay, so there is a we no need to do permute because let's run this and see. Okay, so this is what we needed. So but this ChatGPT has used permute, which is wrong. We'll see why in after some time, because we'll be using permute at the end. So this looks good. So here you can see one data from each class. And we no need to worry too much about this code. This is normal matplotlib. Our focus is deep learning. So instead of wasting time writing all this code, we just use ChatGPT to do that. So now let's do some transformation. So in PyTorch, there are so many transformations. For example, let's say this is an image. You want to convert that to a tensor. There is a function or transformation for that. And if you want to normalize the data, there is a transformation for that. And if you want to randomly crop something, there is a transformation for that. So we will be learning so many transformations in our future sessions. But for simplicity, we'll focus on only two transformations today. One is I need to convert this image to tensor. So that's one thing. And then the second thing is I want to normalize the dataset. So, but before putting anything to the model, we need to normalize the data. So we will be doing those two transformations today. We'll see. But before that, let's check what are the available transformations in the library. From Torch Vision, import transforms. Then dir will tell you what are the available objects in transforms. So you can see there are so many transformations: random crop, random erasing. Okay, but for our session, we'll be using only two. One is to tensor, because if you see the input data is an image, not a tensor. You can see it here. So this is an image. So that's why we are directly printing the image. But for modeling, we need to convert that to number. In PyTorch, everything is a tensor. We need to convert this image to a tensor. We are going to do that now. Cool. We already imported to tensor transforms dot to tensor. So this to tensor is like a function. Now we are storing that function to tensor. So now tensor takes an image and convert that to a tensor. Let's do that. So image tensor equal to tensor of an image. Then let's print its shape. Okay, so we need to create an image dot class, sorry, or use label c410 0. We are taking the first image and then we converted that to a tensor. Now we are getting shape 332 by 32, which is 3 is RGB, 3 channel, and then height and width. So now what we are going to do is we are going to convert everything to tensor. So, and also we have to normalize the data. So maybe first let's try to convert everything to tensor first, and then we will see what are the normalization we can do and how to do that. So let's convert everything to tensor. Tensor underscore c4 10. So let's use the same code. Train equal to true, download equal to false, then transform equal to transforms dot to tensor. So we can add a transform parameter inside c410 from Datasets class. So let's run this. Okay, so let's take an image and see what we are getting. Image t label equal to tensor c410 0. So let's check its shape. Okay, let's check this shape. Okay, if you see all the data, it's in 0 to 1 range, because the two tensor converts everything to 0 to 1 range. Let's print these things and see whether that's in 0 to 1. Okay. So now let's try to print an image and see what happens. So previously, if you go to ChatGPT, it suggests us to use permute. So now we are going to use permute. I will tell you why. If you see plt.imshow image t, let's see what happens. So we are getting error. It says invalid shape 332 by 32. The reason is in matplotlib it uses height, width, and channel, but PyTorch uses channel, number of channel, height, and width. So we need to shuffle these things. To shuffle these things, we'll be using permute function. Dot permute. So we need first dimension, then second, then put the channel at the end. So it's like height, width, and channel. Now let's run this. Okay, so now we can see some frog or something. Cool. Okay, so now let's collect all the images together, and then we will find what's the mean across each channel and what's the standard deviation across each channel, so that we can normalize the dataset. Okay, let's calculate the mean across three channel images dot view 3 comma minus 1 dot mean dimension equal to 1. So this gives us 3 number, which is the mean across each channel. Now let's use the same to do standard deviation. Okay. So now we can use these things to create datasets using PyTorch. So how we are going to do is using the same code. Maybe let's copy, paste, and then modify. Okay, C410 datasets.c410 train download equal to false. Transform. In transform, what we can do is we can pass many things using transforms.compose. So let's do that. Transforms.compose is a function that takes a list of transformations. So our first transform is to tensor. Then after that, we can pass normalization. Transforms.normalize. In normalize, we need to pass two values. One is mean and standard deviation. So mean these numbers. And standard deviation. These numbers. Good. No transforms dot. Okay, it's a capital letter. Okay, I accidentally deleted the extra. Okay, this one. Okay, now let's change this to capital C. Okay, it worked. So now we are going to do the same thing for validation. Just copy, paste, C410 val, same download train equal to false. That's the only change. So now we got both training data and validation data. So now let's try to do some modeling. Let's pick two classes. Maybe let's pick just airplane and bird. So let's get, maybe what's the name? Classes. Class names. Okay. So we know that aeroplane is 0 and bird is 2. So we can create a label map and we can extract those information from these two datasets. So label map equal to 0 is 0 and 2 is 1. Class names, airplane, bird. Now extract these things. C4 2 equal to, we need to image comma label map of label for image comma label in C410 if label in 0 comma 2. Okay, this code will select only if the label are 0 or 2, which is aeroplane or bird, and then convert 0 to 0 and 2 to 1, because these numbers should be ordered. So that's why we are doing changes here. Now let's do the same thing for validation. Copy cipher to val, then cipher 10 val. That's the only change. Let's run this. So previously our dataset training dataset size is around 50,000. Now let's check the size. Length of cipher 2, comma length of cipher 10. Okay. So for cipher 10, the dataset size is 10,000. This cipher 10 dataset has 50,000 data points. For each class, we are having like 5,000 data points. Here we have only 2 classes, that's why it's 10,000 data points. Good. So now let's quickly build some models and see what happens. So PyTorch has a module neural network, torch.n as CNN. In our case, let's import this first. Then let's use a model nn.sequential. Before going there, let me use image.shape. Okay, so if you see this image has 32 by 32 and then 3 channel. So what we can do is we can flatten everything. So how to do that is before going there, let's multiply these numbers and see what we are getting. 32 multiplied by 32 multiplied by 3, 3072. So what we can do is we can create 3072 neurons like input, and then from there maybe let me draw this. So our images is like this: 3 channel, 32 by 32. What we can do is we can flatten these, so we can get, maybe let's say this is R, and let's say this is G, and let's say this is B. Assume this has 3072. Then we can create a hidden layers, let's say 512. Then everything is connected, which is fully connected. Then finally we will have like 2 classes, one for aeroplane and another for bird. This is also fully connected. Then let's say we pass a bird image, we'll get a number like 2.3 for aeroplane and 10.7 for bird. Then we will use these numbers to some loss function. That loss function will tell you how good this model is, and then it updates all these weights and biases so that the model will be more accurate. So we are using a linear function with 3072 as an input and 512 as a hidden. So that's our first. Then we can pass this to an Can you hear me now? Yeah, I hope the audio working now. Maybe let's wait for Tim's confirmation and we can choose. And Tim asked, why did you choose 512 neural nodes for first layer? So it depends. We can use any number. I thought some 2 power should be good. We can also use 256 or 1024, those kind of numbers. So let's use 512 for now and see what happens. Okay, so now we got a model. We need to construct a loss function. Maybe maybe I'll talk about the loss function in our next section. But for simplicity, let's use a loss function called Softmax. So I will tell you why we are using this in the next session, because that needs a little bit of background. Thanks, Peter. Cool. For simplicity, let's assume normally we use Softmax for these kind of problems, like we are predicting 2 different numbers. So Softmax is a good number. But in the next session, I will spend roughly around 30 minutes just on the loss function, because that's very important to understand. That might take a little bit longer to understand. So let me just use Softmax for now, and we'll learn more on that in the next session. So what I'm doing here is nn.sequential that takes nn.linear. Maybe let's rearrange so that we can read properly. Okay. 3072, 512, then relu, then nn.linear 512, 2. Then we can add Softmax, which is log Softmax. Dimension equal to 1. Okay. Let's run this. So now we are going to create our loss function. Our loss function is negative log likelihood. Triple L. Okay. So I will explain this part and why we are doing Softmax in the next session. For regression problem, we can use mean square error, which is very straightforward. This is also a little bit straightforward, but it's good to spend more time on learning with different numbers and what happens when you get a high number, what happens when you get a low number, why we are using log here, those kind of things we'll learn specifically in the next session. Okay, so now let's take an image and pass it to the model and calculate some loss. So image label equal to CIFAR2. Let's take the first data set. Let me check my audio, because when I touch my microphone, it get disturbed. I hope, okay, it's working. Cool. So let's take the first data, image and label, oh sorry. Okay. So now we are passing this to, let's take some prediction. So the model, we need to squeeze everything to a straight number, because it's in 3 by 32 by 32, but we need to flatten everything so that it becomes 3072. Let's do that. Also, in the upcoming sessions, we will spend 1 or 2 sessions just for learning more about PyTorch, how to transform the data, these kind of things. Instead of just focusing on deep learning, we will just spend more hours on learning PyTorch in depth. Okay, so this flattens. Then let's pass this to the loss function. The loss function take the final prediction and then real label. Let's find the label. Okay, so this will give you some number. So currently we are getting 0.78. and this is our loss. From this, our model will update train. So with this, maybe let's do a model training. So let's copy this so that I can write everything in the same cell. Okay. So let's choose learning rate 1e minus 2. Let's choose optimizer optim dot b. Let's use atom model dot parameters learning rate equal to learning rate. Then loss function nn dot negative log likelihood loss. Then let's train for 100 epochs. Okay. Oh, I need to import optim. Import torch dot optim as optim. Good. Let's run. Oh, sorry, I added extra. Okay, let's run this. Okay, it works. Let's print the model. Okay, sounds good. Now let's write a training loop. So whatever we have seen in the previous session, for simple problems, we are going to use the same training loop. So nothing changes. For epoch in range, number of epochs. For each data, image, comma, label in cipher 2 out equal to model image dot view minus 1 dot unsqueeze loss equal to loss function out torch dot tensor label optimizer dot zero grad, then loss dot backward optimizer dot step, and after each epoch print the loss. Okay. For epoch loss is loss. Okay, so let's run this and see what happens. It might take a while because we are not using any batch. We are taking data one by one. We are not using GPUs efficiently. We will learn all these things on our coming sessions, but for simplicity, let's run this code and see what happens. Maybe even if you cross like 10 epoch, we can stop there. The loss is really high in the beginning. we are using Atom optimizer and ReLU. Maybe that's more efficient in converging. Let's see if you're getting 0 one more time. It's a very simple problem, so it's not training really well. Maybe let's change because we are using data one by one. Maybe Atom is like a oracle. Let's use stochastic gradient descent. Maybe instead of doing 100 epoch, let's run 10 epoch. If we see some decline in numbers, then that's good. So this looks good to me. Let's see. Let's check the second number. If the second number is less than this one, which means it's converging. This is also surprising. Oh, it's overshooting. Let's check our learning rate. Learning rate is 1e minus 2. Maybe instead of ReLU, let's use tan h and see what happens. Because this dataset is too simple. Okay, this looks good. 7.8 and in epoch 1 2.6. Let's see if it converge or not. So while the model is training, let's copy some code and use ChatGPT. And show more. Let's check any error in our training. This looks good to me. Okay, let's check this one. Model image.view -1 dot unskews. Okay. I hope you can hear me now. So no audio since ChatGPT. So what I did is I used ChatGPT to get some validation results, and we are getting close to 67% accuracy. What we are going to do is in the next session, we will build on top from here. Like we'll use the same code and we'll improve the model accuracy to close to 98 or 99% accuracy. Then we will learn more about other different architectures like convolution neural network, ResNet, and many more. I'm going to end my session here. The next session will be conducted in Brisbane offline by Tim. I think he will provide more details on our Slack channel, as well as there is a meetup page already created. Please sign up and see you all next week. Thanks everyone.